Okay. So let me go back to PGAdmin, which is here. Okay, so you have, as I said, this hierarchy. This is the object browser, right? It shows you all the objects that are involved. It's really complex, and you can actually, if you want, you can simplify it. You can go into the settings and determine which things you want to see. But right now we're seeing everything, which is a good way to start, I think. So we've got one server, right? And the server in this list of servers is Postgres SQL 11. You could name this. If I right-click on this, and you look at the properties, there are things you can do, like the name. You could change the name from Postgres 11 to something else like localhost. You'll notice that it has a connection. It is called localhost, actually, because it's our only one. Right? You can have named instances, and you can have one localhost. This is the default port. You shouldn't change it unless you know what you're doing. The maintenance database, which is the system database, is Postgres, and the default user is Postgres. We'll talk about that, especially when we get into security. Postgres is, everybody knows that Postgres is the super user, and you should give Postgres a really horrendous password and set it aside and not use it anymore. And if you're doing this for production. So I'll just cancel that. So under this, you have databases, and I'm just going to close that. So we have 3 databases, it tells us. And then under the databases, you have login and group roles, and then you have table spaces. All right, so the databases you kind of know. I mean, the database is where the data is stored. But there's a lot of secondary structures that go there. Login and group roles is where the security happens. It's where you create the authentication, give permissions, and all that kind of thing. And then table spaces are for basically setting up the disk space that the database will be in. There's a default table space, which everything is on right now, but you can create other table spaces. They are not necessarily physical disks, they're logical namespaces, but they can represent, because when you create a table space, you say where it's going to be. They can be on other disks. Does that make sense? You can spread a database across multiple disks, which is a good thing to do, particularly if it's going to be large, really large. It also can be useful for, like, if you're putting it on a RAID system or something like that. All right, so let's look at databases again. So we have Community Assist, text certificates, and Postgres. Again, Postgres is the system database. It keeps track of other databases. It keeps track of what's on the server. Generally, we don't want to mess with it. So I'm going to open up Community Assist. Some of these I'm going to let you guys kind of look up. CAS. There's nothing in most of these. There are some things in catalogs. These are system databases also, but they're system databases for this database. So one of the rules of a relational database is that everything is kept in tables, even information about tables. So some of the things that you can do with these are you can search the column names and the data types for the columns. You can search what tables there are. You can search what indexes there are. You can search what keys there are, right? So it's all meta information about the database itself. Even the tables that are storing the data, meta information, have their meta information in the tables. Does that make sense?
Where does it stop?
It's probably close to an infinite regress, I think. But these actually do pretty much the same thing. The 2 versions of the same. Notice this one is called ANSI, American National Systems or Standards Institute. This is the ANSI way of doing it. So this consists mostly of predefined views that allow you to see the data. If you open any of these, you'll see hundreds of views. Not hundreds. How many are there? 67. This one The Postgres is a little bit different. The Postgres is actually the actual table storing the meta information. ANSI are the views. The Standards Institute said that you should create views to show the meta information rather than give people direct access to the underlying tables. Because if you mess with the data in the underlying tables, you could destroy the database, right? So these are views of the underlying table, but these are the actual tables, and Postgres will let you mess with them if you want. So, but if you do, just be aware that you might destroy your database. Event triggers are triggers that are on the database level as opposed to the table level. Extensions, you can add extensions. Do I have any? So I have added a couple. I added PyCrypto. PyCrypto is, or it's PG Crypto, is a library that allows you to hash and encrypt things. PLP, SQL, GSQL is always there. It's a extension of the SQL language that allows you to do some things that normal programming languages do, such as loops and ifs and things like that. Almost every database system out there has added those features, but they're not actually ANSI standard. And this creates universal unique identifiers. So the things you can add, lots of extensions. These are things that aren't there, but they're libraries that you can add. Does that make sense? There will be a place, there's one place where we will add an extension later. Foreign data wrappers. I'm going to let you look that up because I'm not sure I can explain it. Languages. We've got the PLP GSQL. That's an extension again. You can add other languages. I'm not going to do this now, but you could add PHP. You could add Python. You could add C. I mean, you can have, and then you could, in your query window, you could write C code as well as SQL code. Some databases have this. You can do this with SQL Server too, mostly for C# or C++. It will let you do additional things in C++ or C#. For our purposes, the schemas are the most important thing. Schemas are ANSI standard, although I've only seen Postgres and SQL Server are the only ones that implement it this way, but this is the way that the standard said, because they're free floating. A schema is a collection of objects. It's actually an extremely overused word in a database, because it's also the structure of a table, the structure of the database itself. But schemas here represent ownership. And one of the things that we will do later is we'll create other schemas. And you can put objects in those other schemas, and it's like bundling them. And the nice thing about that is when you're doing security, you can assign permissions to all the objects on a schema. So if you bundle up a schema, make like an employee schema, and then you create an employee role, the employee role can just assign permissions to the employee schema rather than having to go through every individual table and every individual view, things like that. So anybody know what FTS stands for? I'd be surprised if you do, but that's fine. That actually sounds good, but it's actually full text search. So one of the things, if you're doing this as a back into a database website, you can set up full text search so that people can type in kind of vague search terms, and it will actually search all of the text in your table or database. It's not super easy to fix that because you have to create some dictionaries, some templates for it, etc. We might play with it if we have time. Foreign tables we probably won't play with. I just wanted to mention that. These are tables that are linked to other databases or other servers. So they're linked, they're foreign. They're literally tables that come from somewhere else. But you're including them. One of the ways you might think about it is if you had a retail database where you were doing kept all your inventory and all your sale information and all of that, and you had a separate database that had to do with all of your employee information, human resources, but the two needed to interact. You could add a table for the employee names or something that would interact with your database. So it would be a foreign table because it's coming from a different database, but it's linked into these tables. Does that make sense? Functions, there are lots of built-in functions, and you can make your own functions. A lot of them are pretty obvious, but just that you always get those for free. Materialized views, we'll talk about those. They're just views that actually store the data. Most views do not store data. They're just filters. Procedures are for stored procedures, and that's new with version 11, so you might not have that if you have version 10. Sequences. Every auto number sequence has a name. And these are the names of the sequence, the auto number keys for every table. And then we have the tables. Triggers are table specific. Well, trigger functions aren't, but for every table, notice for grant type 2 here, for instance, there's triggers. You can write triggers for those. And I think that's about it for all of those. I'm going to have you guys, one of the assignments is to go through and kind of look up what each of these things do. Again, the logins, we'll talk about those more when we do the security. There's some built-in roles. I usually find the built-in roles much too generic. So you can read all settings, you can read all server files, you can read all stats, you can scan all tables. And these are actually none of them give you real permissions just to use the database stuff. Postgres is the owner, right? And we're going to make a role here in just a second. Questions on those in the objects. As I said, it's a really rich object set. There's a lot of pieces to every database. And you can, see if I remember. I'm trying to remember where it is that you can limit what you see. Might be the object browser itself. No, I'm trying to figure out. I'll figure it out. But I know you can limit what you see here. So let's create a super user based on the who you are. Now this could be problematic for you if you're moving tables. Well, actually, so one of the things, this database on these machines will be only on this machine, but it is public to all profiles, so other people could screw with it. That's one of the reasons why virtual machines are good. And if you log into a different machine, your user probably wouldn't be there. Does that make sense? So, but I'll do it anyway. We'll create a user. I am going to right-click on Login and Group Roles. I'm going to create a login and group role. We'll do a lot more of this when we do security. I'm going to give it my login name. Don't give yours my login name. You can. I guess it doesn't matter in some ways, but so then I need to go to definition. And password, I'm going to just do password because I haven't reset my password yet. And I don't necessarily want to type it out for. The thing is that what would really work here, again, for now, I would just adjust password. But when you're doing it at home or on your own laptop, you may want to put your laptop, your admin password here, because then it'll go through transparently. Does that make sense? That when you log into Windows, you're also kind of logging into this. And that can be useful. But I'm just doing password 1. I'm going to go into privileges, and we're going to add some privileges. Later, we're going to do this with SQL, because you have a lot finer control with SQL. I'm going to say can log in, yes. Super user, yes. All right. I'm going to let him do this too. So I'm going to give all the permissions to this person. Generally, you want to do this for like 1 user, maybe 2, in case the 1 user gets sick or hit by a bus or something. You don't want very many super users. Generally, you want to log into a database with the minimum amount of privileges you need to get the job done. You don't want to log in as super user generally because you can do a lot of damage, even by accident. You know, if you do accidentally say delete star from sales, all of your sales could be gone, and there's no quick recovery. And you could do that when you were meant to doing something else, you know, just particularly if you come to the database late at night or if you've been drinking or something. You know, you could do some real damage. So it's not a good idea to log in as super user unless you need those permissions. But for us, we're going to generally do that. The other thing I'm going to do, I'm not going to do parameters or security because there's really not much to do there. So I am going to show you the SQL. So if you click on SQL at the end, it will show you the SQL that you could write to do this same task. Most of the dialog boxes have that SQL tab, and it's kind of a good way to learn. So create user sconger with login super user, create database, creator role, inherit, replication, connection limit. -1 is the same as unlimited connections, and then the password, which is just Xing out, but it's there. Does that make sense? You don't have to run that SQL. We can just do this. We can just save it. So down at the bottom here, this went up instead of down. There is now an sconger user. To log in, this is a bit of a pain, actually. It's actually easier in the command line, but we'll do it here. I am going to right-click on the server, and I am going to disconnect the server. You might be able to create a second connection with the same server. I might try that later. I disconnected it. I'm going to go to the properties, connection, and I'm going to do the username as sconger. I'm going to save, and then I'm going to log in again, and I need to do my password. And again, if you left it in here, and then I've logged in here. And because I'm a super user, I have everything. Later, when we do security, we'll show you users that don't have permissions. to do everything, and we'll do it. So I'm now logged in as Conger, and I could leave it this way if I wanted, so that this is the account I log into every time. That's probably actually better. But again, anytime you want to change the user, and this is a pain, you can stop it. Let's try to add another server. What happens if I do that? There's only one physical server. I don't know that this will work. Let's call it. What do we want to name it? Localhost 2. Okay, so actually it needs to have a. Now, this is the default port, right? I think. This probably won't work. Actually, let's do the. I don't know if I can have two servers on the same port, though. Oh, let me. So it looks like I can do. This one is logged in under Conger, and so is this one, but let's stop this one. Actually, so I want to disconnect server. Properties, connection, Postgres. Oh, that's localhost 2, cancel. So I'm playing, but I'm curious. I hadn't done this. So you can have multiple connections to the same server. So this connection is Postgres, and this connection is Conger. That actually will save us a little bit of logging in and out later. So when we're doing, we can test things. We can have an admin one and test it with another one. I didn't know you could do multiple logins. I mean, multiple servers like this to the same server. But that's good to know. I don't know that I need to leave both of them up. Questions? Creating the user, things like that. Now, the databases, this isn't actually due until next week, right? We have the databases. I talked about adding a database to and I'm just curious about, I'm going to create a database. This is part of next one, so I'm going to call it TestDB. You don't have to do this, but I want to make sure it's template 0. Oh, I know what I would need to do. Before I do this, let's create a table space. This is actually the part I want to know.
This isn't working for me.
So if I do test, you know what? It probably will work for me. So I need to give it a location.
So who would be the owner of this?
It has to be post. Part of the problem is it is, I think, Postgres. So I just created a. I know you can't see that. I just created a folder called PG Table Spaces on C drive.
And what is that?
That's where I'm going to put the table space. So and then I'm going to give it a name. So I'm going to save that. Yeah, it doesn't exist, I know. So test table space is there, and I could put a database on it. But I have admin permissions and you don't.
It works when it's the directory I was trying to put it on is a child of the C drive, like a direct descendant of the C drive.
Right.
What I was trying to do before was have it be a subdirectory of like my ITC226 folder within my documents folder.
It won't do that. And in general, this is true of databases in general, they rarely will do a profile specific folder.
Okay.
Because
is there a way to make them do that? Or?
I don't know, because they want, the nature of the database is that it's system specific, not profile specific.
Oh, okay.
So generally it needs, that's why I did C drive.
Okay.
SQL Server is the same thing. You can't put the data files on in your documents. You can't put them on the desktop. But it did work if you put it on C drive. That's
Yes.
good to know, because
Yeah.
I just wasn't sure if you guys could do that.
No, it was in a subdirectory in C drive called PG table.
Right, you cannot write, in Windows in general, you cannot write directly to C drive usually. You have to create a folder on C drive to write to.
Table spaces is the only place you can save a data file.
So yeah, and there's a default data space now. Now this is there's nothing in it right now, right? It's just an empty folder for the table space. But if I create my database, so I'm going to do create database, and I'll do my test DB. And if I go to definition, and then we do template 0, table space, test table space, collision, I'm just going to do English. Character type, I'm just going to go with the default. Okay, everything's there. When I save that, all right, just with that, when I go to here and zoom up, so now there's a folder in that, and there's all sorts of subfolders in there too. These all relate to the database. Couple of things about database files, and this is true of all database files, they are not meant to be humanly readable. If they were, they would be security nightmares. They can only be read through the database software. So what we've done is we've said that this file will be here. And this file, logically, this file would probably be on a different disk or a different drive, you know. Couple of things, you can't distribute totally. I mean, the disks have to have some proximity. It's not like Mongo, where they can be spread across the internet. Generally, these need to be in a cluster of related disks that communicate with each other. Does that make sense? with a relational database, the way you get big is you get more and more disk space. With a non-relational database, you can often spread them across computers across the internet. Somebody told me once, I don't know if this is true, that Postgres is the database that drives UPS. Not parcel service is Postgres. And as I said, it's getting a lot of good press lately as being actually what a lot of people say is that it's a good alternative to Oracle. Because Oracle costs you lots of money, and this is free. And yet it has a lot of the same features that Oracle has. I think I'm going to call that for the day, unless you guys have more questions and need to do things. So what I will do, I mean, the database things you're welcome to work on if you want, but there will be time next time. There are, let's see if I can get to, stop.